So hello everyone. Today me and my friends are going to present a topic named as Cybersecurity and Internet of Things. So coming to Internet of Things, IoT, it seems like everyone talking about it, what exactly it is. For our purpose, we are going to describe IoT as a network of separate but uniquely identified devices that sometimes have the ability to talk with each other without requiring human to human interaction or human to computer interaction. There are some devices that we use in day-to-day life, things like Fitbit, Apple watches, mobile telephones, smart TVs, a refrigerator, etc. are all come into IoT devices. However, there are other devices that you may not think of. There are some devices called as smart grid for monitoring electric consumption, even healthcare related devices such as pacemaker, insulin pump, or even a driverless vehicle. Next slide. To put scope of IoT into some kind of perspective, let's have a look at some numbers. In 2008, we saw the number of connected devices surpasses the world population of approximately 6.7 billion. In 2015, approximately 1.4 billion of smartphones were shipped by the manufacturer globally. In 2020, it was predicted that we'll have 1.6 billion of smartphone users. World population was expected to 1.7 billion at that time. And by 2027, it is expected that we'll see 27 billion of machine-to-machine connection in the industrial sectors. Also, let's have some number for you to consider. In 2013, devices connected to the internet generated 1.3 zettabytes of data. In 2014, that number jumped up to 8.6 zettabyte. In 2008, that number is expected to rise up to 400 zettabyte. So coming to zettabyte, what is zettabyte exactly? Technically speaking, it is 1 trillion gigabyte. According to Cisco, 1 zettabyte would be equivalent to 36K years of high definition of television video, or it is equivalent to streaming the entire Netflix catalog up to 3117 times, and that's just 1 zettabyte. So it's a lot of data. Next slide. Coming to new security and challenges, the complexity of IoT security necessitates a bottom-up organic process to ensure the outcome addresses all the existing and the potential challenge and issues. The approach should be fluid in nature, refined through discussion with stakeholders. It is also important to start to work on educating consumer and for the businesses to begin adopting the best practices that will reduce the risks of consumer IoT devices adoption. Next slide, please. IoT in businesses. There is no question that the rapid rise of IoT is more than just a digital disruption that impact the business of all sizes. In fact, IoT presents numerous opportunities for the organization to improve in total efficiency, serve consumer better, enter new market, and even build a new business model. David, in his interview, stated how if something involves processing and transmission, then it is something his company is concerned about. In some way, that show the most organizations are in the early stage of adapting the offering of the new IoT world. However, over the time, IoT ecosystem will become very complex as more and more IoT devices will come online. As the IoT device become crucial for keeping up with the fast-growing market, businesses and technology leaders must be mindful of security implication of the new technology also. Cybersecurity is already a major concern for the companies, but IoT deployment make it much tougher for the executive to answer the question that the corporate board are asking with a growing frequency. That is, has IoT increased the exposure of cyber threat? A major reason as why this is such a difficult question to answer is that most executives are not overly familiar with the challenges of IoT present. There is also an absence of framework that would help an organization to identify IoT related risks and put the proper control in place. However, that is changing. The company AT and AT has 4 part of framework that is able to gauge the IoT related risks. Other companies are also working on their footstep. The further part is going to explain by PRITI HARIJAN.
Okay. Now let's have a look towards industrial sector and IoT. The industrial sector focuses on producing goods The example of business in this area include automobile manufacturers, example consumer electronic companies, the energy sector, and the pharmaceutical industry. Let's take a little bit about each of them. IoT continues to play a role in each of these sectors. The automobile industry has seen advances in everything from sensors to artificial intelligence. A car can pair up with a smartphone, offer real time traffic alerts, stream music, and connect to emergency roadside assistance by touching a button. Talking about consumer electronics, users can monitor and control refrigerators, washing machines, and other appliances using apps. Vendors like Fitbit offer wearables that offer various functions that keep a record of number of steps taken. IoT's role in energy sector cannot be ignored. Some of the IoT enabled solutions in this area includes smart meters, smart grids, and pipeline monitoring. Smart meters keep consumers informed while also allowing for accurate billing and demand forecasting. Billions of dollars are lost each year in the United States due to electricity being stolen. Smart grids have the capacity to detect where power is being lost. They also enable remote control and automation of grid equipment to help keep cost down and reliability up. Now let's see a briefly about a smart grid in IoT. Smart grid in IoT is basically an electricity network comprising a system of hardware, infrastructural and software possibilities. It enables two-way interaction between all the system components and also provide optimal power generation and its efficient sharing. In lemon words, you can say making smart grids include protecting future power supply when there is a limited power generation capacity. Thus, smart grid reduce losses, optimize energy demand disbursement, increase efficiency, and even make huge scale renewable energy installations practical. Let's have a look towards the IoT applications in smart grid. Some examples of IoT applications in smart grids are Germany has implemented a smart grid project in Mannheim. This project enabled the wide adoption of renewable energy and has enabled coordination among energy consumption and production in the city. The next one is the Lumen Energy Management Platform is a good example of IoT application in smart grid. It enables cost savings, reduce emissions, and easier adoption of green energy at the same time. Thus, the company offers data analytic tools and a smart panel in order to optimize storage and electricity consumption, and also to facilitate the connection of PV systems in homes. Finally, almost 3 millions of pipeline crosses the United States alone. Monitoring for problems in these lines is vital for safety. IoT allows this to be done automatically. IoT implementations in the pharmaceutical manufacturing sector allows for real-time visibility about the plans for equipment availability and utilization. It also in many ways ensure compliance and an opportunity to respond in real time for exceptions. Now let's have a look towards some of the challenges which we face in IoT. No doubt IoT offers a very promising future, but there are numerous challenges. Some of the security and privacy challenges which we face in the smart grid are include software and its engineering, software organization and properties, software systems structures, distributed systems organizing principles. In the automobile sector, we are seeing and evolving a challenging relationship between automakers and software providers. In regard to consumer electronics, a major challenge is the issue of interoperability. Not all products are able to talk to each other. In the pharmaceutical industry faces challenges as well. Similar to consumer electronics, the problem of managing a corporate diversity and interoperability is an issue once again. The IoT can potentially play a huge role in the industrial sector. However, that role is not one that is easy for business to define, configure, or manage, because it may be tough for business to see the value proposition in using IoT devices and concepts. They may be slow to adopt the technology. Businesses also have to contend with security and privacy related issues in this space as well. There are legitimate concerns about protecting customer and patient data, as well as protecting sensitive business areas that our competitors may find value in exploiting. Organizers may also find some benefit in the integrating social media with their IoT processes and controls, but needs to be sensitive to information leakage that could prove to be harmful to themselves or their customers. It is interesting to see that in certain ways, IoT in the industrial sector solve long standing challenges. IoT is able to connect things, collect data, and derive insights based on data that is captured, all of which reduced costs, improves productivity, and increases revenue. That's all from my side. The further presentation will be continued by Nimitha.
So I will be talking about IoT and the connected home. Here we are talking about smart home system. Smart home is an all-in-one solution that connects your home, activities and IoT technology to create a comprehensive, safe, comfortable, convenient, energy-saving smart home system. Nowadays, smart home system and devices have become more user-friendly and interact with users. Internet and IoT technologies have been used to connect various devices, including lighting system, temperature regulation, curtain control, etc. Users can control these devices remotely through mobile phones, tablets, and touchscreen panels. Super convenient to manage between your daily routines, home appliances, and smart home devices. Smart community. So smart community platform can support many applications. We elaborate on two major applications, neighborhood watch and pervasive healthcare, which improve community safety, home security, etc. Now we also introduce several value-added services, including smart metering for utility management and social networking for convenience and entertainment. Let's go to Neighborhood Watch. Neighborhood Watch is a traditional program in North America. Similar system is in Europe. They are usually implemented as a function of a community association involving a group of residents devoted to crime and vandalism prevention within a neighborhood. When suspicious activities occur, members contact the authorities rather than intervene. Then we'll go to pervasive healthcare. It is used to make an accurate and quick emergency response. The applications rely on continuous monitoring and the environmental conditions of the body status of community residents provided by a wireless body sensors deployed around the human. First comes the utility management. Now here traditional automated meters, we have to read individually by metering personnel from utility company. In smart community, each home is equipped with smart meters to identify utility consumption, where the data goes to the community center through the community network in a secure and privacy preserving manner. Then comes the social networking. Here, the smart community environment also provides a social network platform. It is convenient and cost-free for the residents to utilize the community network to interact with each other in local. Is the risk in connected home? Here it says 62% of US adults own at least one connected device, and almost all IoT devices are currently connected to the internet. Here as we can see, 88% are connected to voice command systems, 80% to smart home devices, and 69% are appliances. Now, some IoT devices are always on, while others connect to your smartphone, computer, or tablet throughout the day. These are the IoT devices as shown. Now, here The risks are as follows. The cyber criminals can access IoT devices at any time, using them to hack into connected devices, compromise your physical safety, send malicious or spam emails, stop your device from working until a ransom is paid, steal your private data, and also they can interface with financial transactions. So the factors. Now let's go to the security. And so the factors to be considered for home connected security are as follows. Most smart home devices are fixed function devices. Once they are shipped, they cannot be upgraded to add security after the fact. Smart home devices are special purpose devices, not general purpose devices like PCs or servers, and as a result require special purpose security solutions. Once deployed, the devices cannot be upgraded to add security fixes until the device manufacturer provides an upgrade. The end users cannot buy security software from the third party and install it on the devices. There is no one to manage security within the home. Now let's go to the future of smart homes. As you can see, we have mini microphones. Microphones throughout the home will give us user access to voice assistance no matter where we are. Then we have light up walls. Light up walls are like hanging light fixtures will be replaced with energy efficient luminous walls that provide light throughout the home. Then we have robotic kitchen arm, tech free room, health sensors, 3D printers, rollable televisions, smart shower, shape shifting furniture, and so on. That was my part. Now let's move on to the next part, that is the IoT and consumer wearables.
So myself, PRITI Gundigara, I am going to discuss about wearable devices in Internet of Things. Wearable devices are the devices which are incorporated in the body or in the accessories. So there are wearable devices which are categorized in a type of types, such as the accessories which are worn, embedded in the clothing, implanted on body, tattooed on skin, smart glasses, such as activity trackers, 3D motion tracking, smart watches, etc. Next slide. So this is the survey slide. This is the survey on the type of data collected with the wearable devices. It is segregated into 4 parts: upper body, lower body, head mounted, and wristband or handheld. Upper body, the type of data is collected in this is EEG, ECG, whereas tracking of health of your body and the body temperature. In head mounted, there are type of devices such as VR, virtual reality, then glasses, smart glasses, and the camera. So they have collected the data of your surrounding, such as photos, videos, and audio files. And there is the third type, lower body, the number of steps you are walking, your locations, and there are some smart belt devices which can also calculate your body size. And there is a smart watch which will collect all your data, such as your body temperature, your heart rate, your locations, the bills you have paid. So these types of data are collected in this, and where this data is used, we can say that in Western countries nowadays they are using or they are sharing this data to the companies which are providing health services or insurance, so they can consider all this data, all our day-to-day activity, and they can provide us for the better product. Second, next slide. So there are many challenges came for wearable devices. So in wearable devices, killer apps, as there is very much competition in the market, so they have to increase their best technology, whereas they have to give best user interface to the user. In power management, the devices are getting very compact, So the battery management system is also getting smaller and smaller. So engineers have to get the best battery management system and give the best experience to the user. In the technology dependent side, the user is getting too dependent on this technology. They are getting very furious and anxious about their goals, steps, as they are getting all the data on their fingertip. And the software and architecture. Software architecture is leveled in 4 levels: user interface, data which is sensed by sensor, and there is the phone and the internet. So the user interface will give the data which is sensed by the sensor, and that data is stored into storage, and through storage that data goes to phone, and through phone which is connected to internet, it goes towards the data center in backend. And this is the software architecture of the wearable devices. So their challenge is that the phone is now getting excluded from this, and they are making direct contact through wearable devices and internet. And this is the person area network, you can also say PAN. So this is where your smartwatch and phone is connected to each other, and they communicate and transfer their file to each other. So the data which is sensed by the sensor, it should be more accurate and real time. So the data latency, whereas the transfer speed of the data should be at the real time. So this is the challenge faced by all the engineers in wearable devices. Security, we will see this in the next slide. Next slide. Security. We just consider the scenario where an individual person is using a smartwatch, smart camera which is connected to internet, and a smart door lock. If some third person has a special skill who can crack this into a device, he can collect all your data. He knows all your information, where you have been, where all your day-to-day activities. So he can break into your home, and he can steal all your invaluable items. So there is very much safety, importance of safety in this devices. So now they have to increase their protocols, they have to update their securities and aware about new malwares. So future. So by 2026, the user base is predicted of wearable devices increased by 24.6%, and value is up to 102 billion dollars market of the wearable devices. The new devices will innovate, as well as the gateways, more and more protocols will introduce in the market. New cloud service also introduced. So as there is a quote says, amateur will hack the system, whereas professional hacks the people. So as we people also have to upgrade ourselves and become quite knowledgeable about this. So this is all our topic about cyber security on Internet of Things. Thank you very much.